Okay, so the random junk would be just for testing purposes.
Well, testing purposes is also what people would probably upload if they could.
You're not wrong. You're not wrong. Anybody else have an off-the-wall use case?
Yeah, same thing, like looking for different ways to, applications, industrial applications. I work in manufacturing projects between China and Mexico and the US. So I see the potential in industrial applications in manufacturing, but it's just too hard to make the integration.
Right.
Integrate all those different technologies, especially when all that data is needed to the industries, to the companies that own that data. So it's really hard to push them or change their minds and say, hey, now can we use your data to train new models so you can improve your processes in manufacturing?
Can't help you with that part.
Can you just create random synthetic data to train those manufacturing processes? It's just so hard. You have to really
My own career as I was a business professor teaching manufacturing.
So I'm talking about
yes.
the robotics,
Yes.
all the different highly specific processes that you need to
That raises
work with.
That raises a really important question, which is a lot of the really high value data is proprietary.
Exactly, that's my point.
And it's people are very reluctant to let that go out into the wild for random, for AI experts.
Check. Bueno.
Going back to how do you develop new applications, or how do you work with the industries, right? So you can you pay for that data in exchange for solutions to their problems and processes in different kinds of industries.
I don't know. I mean, it's possible that the idea of synthesizing.
Well, this would be, I think, more like data pipelines, data transformation.
Well, manufacturing, things like quality actual engineering, production data.
Exactly.
Those have very specific structural characteristics to know what the patterns are in general.
Right. We have another use case, so.
Yeah, it's also interesting also different approaches for evaluation. I'm making products based on LLMs, and for me it's going to be a challenges how to make production-ready products and how to evaluate results, because
Evaluation.
there's no usually structured schema or structured there is structured output, but it's difficult to evaluate results from LLMs, and especially from systems of agents. And it's also interesting how to solve this problem in the different approaches.
You could have a whole another session just talking about evaluation. I'll try and maybe weave it in, but I don't know. Maybe you can give a presentation next time about evaluation systems. There's a couple of different solutions, I think, like startups that are developing products to kind of help with it, but oftentimes it just depends on what you're doing. It's kind of more a bit bespoke system, depending on what your evaluation criteria are and what you're evaluating.
You want to get started?
We can get started.
All right.
We got a big group.
So again, thank you everybody. Welcome for coming. Welcome to #gallery. I keep wanting to say Artworks because that's used to be what it's called. Just a couple things before I pass it off to Blake. I'm Ben. As you might have heard, I've been organizing this event for around 3 years now, and so excited to keep doing this for a long time. If you want to speak at a future event, we're always looking for speakers. There's sign-up links in the description of the WhatsApp group and posted on the meetup, and you can just send me a message, however you guys want, but always looking for new speakers. We cover a wide range of topics. You can look at the meetup history for events to see, but we've done things like as simple as turning content, transcribing like video content into written content, that kind of thing, or just how to use AI and basic automations, all that kind of stuff. So we're open to a wide range of topics. What else? Usually we take a couple minutes to do announcements. If anybody else has announcements they want to do for other events, especially like technology events, that kind of thing. Graham, do you want to come say something real quick about the event space here?
Yeah, it's the event space. we got some new art shows up on the 4th of September, so if you're around that day, come by at 7. This side and the other side will both have new shows, and then we have comedy on the 28th. This one.
Please be careful of the art. It is real art.
Don't just in case.
And then he's open to hosting other events if you have your own event, that kind of thing. There's a monthly Python event, Python CDMX. I see a couple people here that I've seen there before. I try and go to that whenever I can. I think the next one is going to be the 9th of next month, though it hasn't been scheduled yet, the exact specifics. So there's that, and then there's also DataPub, which I highly recommend if you're involved in data analytics, that kind of thing. They have a big event every month. I think their event is next week. Oh, is it tomorrow?
Thursday.
It's Thursday.
Yeah.
Thursday. Okay, so it's coming right up. They always have a really good event, and it looks like we're going to do a collaboration with them here in the next couple months as well. So I'm really excited about that. That'll be cool. Next month, it doesn't seem like we have anybody planned yet, though there's a couple people that have expressed interest. So it's usually kind of first come, first serve for those slots. So if you want to speak here next month, that's still available. I think October is Phil. I think we've got a security AI specialist from Mexico who works for the Mexican government who's going to be here and talking about security implications. It doesn't sound like he's going to be able to talk about his job much for obvious reasons, but AI and security, that kind of thing, should be interesting. Any other events? Anybody else wants to say a quick thing? Do you want to?
I'm the leader of the AI collective. So let's talk after, but you are all invited to the next. It's next Wednesday in Torremayor. We will present with the guys of Windsor. Well, the tool and some other live coding, food, and beers, and take a good moment.
Great. And so AI Collective, if you haven't heard, is an international AI group. They host events all over the world, really. And they've been around almost as long, I think, as this group. They've done a lot of great things, and they host pretty big events. So I haven't been to yours yet, but is this your first event, or?
Yeah.
Oh, okay.
We're gonna open the first chapter here in Mexico City.
Okay, great.
Yeah.
Cool. Excited to see that. Anything else? Any other upcoming events anybody wants to promote? All right, cool. Well, if there's nothing else, there's a bunch of QR codes out over with the drinks and stuff. If you want drinks, there's drinks out there. If we have a WhatsApp community that's pretty active with like 150 so members, so feel free to join that. We talk mostly daily about new AI things or different projects we're looking forward to or not looking forward to, or whatever the case may be, getting help from peers, that kind of thing. So please join that if you're interested. And obviously all of our socials. We're trying to live stream for the first time here on X, so hopefully that is working. I haven't really heard back, but yeah, it's working well. Okay, good.
Awesome.
So hopefully the sound and everything on that is working pretty well. And I think, yeah, hopefully.
Try and just make really big hand gestures.
But, all right, well, I'll turn it over to Blake. I think he's going to explain better what he does and why you should listen to him. But Blake's been joining us here at AI CDMX for, I don't know, 2 years now, something like that. Yeah, you were pretty early on, and I've been asking him pretty much since we've met to speak. So he's finally here to speak.
That's accurate. That's
so I'm really excited about that, and yeah, give a little round of hand for Blake.
Thank you. So first of all, thanks to Ben, thanks to Graham, thanks to all you guys for being here. So I got to do quick introductions with some people, not necessarily names, but I got a sense of kind of what people do, what they're interested in. And with that, we got a lot to cover, so let's just jump right in. So we're going to be talking a little bit about narratives today, narratives in the AI industry. That's kind of where we're going to start, because I think that's kind of a common point of entry for all of us. So as far as questions, I'll leave some room for questions at the end. If something is just completely off the wall, feel free to stop me. Cualquier duda, avísenme, porfa. Cool, all right, quote. So this is from Dario Amodei, who is the CEO of Anthropic. So many of you probably seen this. So he said, imagine a world where cancer is cured, the economy grows at 10% a year, the budget is balanced, and 20% of people don't have jobs. So raise your hand if you've seen this quote. People seen it? People heard about it? Okay. So basically what he's talking about is how society is not prepared for the impacts that AI is going to have, and how this is going to come faster than we think it's going to come, and we should be preparing for this eventuality right now. So obviously it's provocative on purpose. Without context, it seems pretty alarmist. Like objectively, it seems pretty alarmist. But how accurate is it actually? So that's not simple. That's going to take me about 45 minutes of your time to explain. So let's talk about the basic agenda of what we're going to get into today. So we'll talk about narratives. We'll kind of start from there, this common point of entry about where we are in the industry, in the technology industry. We'll talk about trends in research and deployment of AI systems. And then we'll talk about applications that we can actually take advantage of today and sort of look towards the future. So the argument that I'm going to try and make to you today is that while current AI applications are a step change, so a pretty big increase in capabilities from earlier versions, I believe that we can better understand them as a progression rather than something completely new. And I think that their effects over time will be much the same. So while this sort of monolithic superintelligence that Amodei is warning against is a theme and probably a goal of those companies, I'm going to argue that it's not the only or best application model to target long-term when we think about large-scale AI systems. And even if it were the right way to go, I'm going to argue that scaling current LLM-based architecture alone probably wouldn't get us there. So I'm going to talk about different research trends and how those sort of complement each other and contrast with each other. And then we're going to apply our learnings and things that we talk about to actual practical use cases. I'm going to sort of pull out two of them, and hopefully those resonate with almost everybody in the room. So we'll talk about what entrepreneurs can take away from this if you were starting a company that does stuff with AI. We'll also talk about what it's like to be a software development professional with these tools starting to proliferate. So my hope is that we'll walk away from this talk armed with lots more context and information about what's already available, and then also be able to better plan for the future. So quick introduction of me. So I am a software engineer. So I have been designing what we'll call interactive systems for a long time, very long time. I've been in the industry working with this for quite a while as well. So I've done over the course of my career a lot with computer vision applications, and then most recently with AI applications. So I'm going to show a couple pieces that I've done over the years. This first one is one that I'm really proud of. When I was still working directly with clients, this is more of a computer vision application for a piece for a client. Pharmaceutical company wanted us to build sort of a large-scale interactive installation for a conference in Las Vegas. So this one has an overhead camera that is set up over the space, and that detects the presence of people moving through. They had this ad campaign where this woman, takes the drug and she has like flowers coming out of her feet all around her. So they wanted to recreate this situation for people in the space. So I was responsible for creating and developing the computer vision system, and then I worked with the other engineers to sync that up with the feedback. And this ended up working really well and being really fun. So my more recent work is I started off working for a startup. We've since merged into a bigger company, but the product that we have developed in that time is a system it's another computer vision system that uses AI to be able to automatically detect damages on the body of cars. So we have systems that are deployed in car auctions all around the US. This video shows a little bit of that. So for this system, it's a tunnel with lots of cameras that take images as the car is going through. And then there's a pipeline that runs and takes all the images, detects the damages, and then outputs a report at the end. So I started off as the principal developer on the original team developing the actual capture system, and then now I work on the other end with the data that comes out the other end. So we can sort of recycle it and make sense of it internally to continue improving the system. So it's from that perspective that I'm speaking today as a builder, as a maker, somebody who's worked on these systems. I know the problems, I know the bottlenecks, I know the pain points. So with all that said, we're going to go through a little bit of context on what's happening with the system like this behind the scenes. What's the technology that underpins a system that drives an application like what we're seeing here? So that involves going through a little bit of the basics of machine learning and a little bit of theory behind that. So if I say that we use neural networks in a solution like this, raise your hand if you kind of know what I'm talking about. So it looks like a lot of people actually have some background. So y'all bear with me. I'm going to greatly simplify things just so we're all on the same page and we're not here all night. So a neural network is a system that is the backbone of most AI systems. And a neural network is part of a technique that we call deep learning. So to explain deep learning, I'm going to show you a graph. So deep learning was a technique that was essentially invented in the 1980s. It was built on techniques that are much older, from the 1940s and 50s. But the idea is that this system is a system that learns, is trained on lots of data. And so that data becomes the basis for a statistical model. So what deep learning does through this process of training, of learning, is it's able to identify features in the data that are then encoded as parameters. So you can think of a parameter in this sort of simplified view as a node in this network here. These nodes, we also call neurons. So neurons like in the biological brain. So with the caveat that this is very loosely inspired by the brain. We're not building a brain here, but we use the term neuron for that reason. So the neurons in this case are activated by certain inputs that relate to these features in its training data. So the first neural network to really break onto the scene in the industry and really make this the focus of research and development and funding going forward was a network called AlexNet. And AlexNet was made famous because it's sort of this canonical example of a network that is able to identify like cat pictures. If you wanted to differentiate a cat picture and a dog picture, AlexNet was one of the first to classify images in that way. So another technological breakthrough that's important for me to touch on in this talk is called the transformer architecture, and this came out of Google research. So this graph shows you a little bit, helps you visualize a little bit more what I'm talking about. So the transformer is what allows human readable text to be encoded as tokens. So tokens in this context would be units of text, not necessarily words or phrases, but often smaller. And what it also has is what's called an attention mechanism, and this attention is what allows the system to be able to apply context to a string of tokens. So tokens are not all going to be equal and should not be given the equal weights. So where the system focuses attention comes from this architecture. So the transformer is the basis of the LLM, or large language model. So large in that there are billions of parameters, sometimes more. Language in that it's largely trained on text, not always, but largely. And model in that it is a machine learning model that's job is to predict the next token. So given a string of tokens, the model predicts the next token. So the canonical example of this is ChatGPT. And that's how we've come to know these techniques as this sort of monolithic service, giant neural network with lots of data inputs and all that. So LLM scale involves training of days, sometimes weeks, data centers of monumental proportion, like this one here. This is a new type of data center that's actually being built in what is more or less a tent. So the demand for facilities like this has become so great in the past couple of years that they're just being like stood up in literal tents. So training and processing, so the training is very compute intensive, very resource intensive, but also the systems that we're used to today don't just do one pass to the model, what we call inference. There's a lot of pre-processing and post-processing, and that's even more compute. So compute intensive, especially with regard to hardware components like the GPU, which you're probably used to hearing about. There's other ones as well. So that's a physical device, and there's a limited supply of those. Everybody wants them, price goes up. So there's also huge inputs of electricity, water, land. Along with the land and all those other things, all this other infrastructure comes regulatory regimes. So this particular facility is stood up in Texas. So a lot of similar facilities are moving to areas like West Texas, where there's really not a whole lot, but what there is already is a very lax, very sort of liberal regulatory regime. So these companies can come in and just kind of do what they need. So this is what it takes to train and run a system like GPT-5. This is what the big tech companies do. This is what only big tech companies can really afford to do these days. So to what end? What is the end game? What's the goal here? So the goal is to eventually arrive at what we call the artificial general intelligence. So what is that? The idea is that it will eventually reach and surpass human intelligence, not just in certain areas like playing chess or Go or what have you, but in all areas. That's why they call it a general intelligence, basically. So, and then it will also have agency or autonomy over decision making, so humans ostensibly are in the loop, but not always, right? Less and less as time goes on. So the strategy of the big tech companies as we know it today is to scale these current LLM-based models all the way to AGI rather. So this would be, both through training and at what we call test time or inference time, which is sort of post-processing. So a lot of what's happening right now with reasoning models or thinking models is the scaling is happening at that other end, sort of after like post-processing, not during training. So what does all this mean? It means that any improvements are being made if you accept this paradigm as correct. And it's correct insofar as this is what's happening right now in 2025. Then improvements in performance are directly correlated to hardware and all these other inputs that I'm talking about. So more souped up hardware theoretically means better performance. So AGI eventually in this case will lead to what we would call a superintelligence. So how does superintelligence differ slightly from AGI? Superintelligence has a dependency on the AI system being able to improve itself recursively over time. So once this happens, the recursive self-improvement gets to the point where we reach what's called the intelligence explosion. If you plot it on a graph as far as performance over time, that's where you get the nice hockey stick curve that just goes to the moon. Scenarios kick in. Speaking of that, I'll show you a graph from a group called AI 2027. This is the AI Futures Project. So these are research and policy experts who have created a theoretical scenario where this intelligence explosion happens. The recursive self-improvement leads to the explosion. So there are two main stages. The first would be that the AI becomes a super intelligent programmer. So programming better than any single human and better than most groups of humans. And then following that, then becomes the best, most optimized AI researcher system. And through that, improves itself all the way to the superintelligence. So this here is fiction. This is science fiction. And it's meant as a warning, much like the Dario Amodei quote. So aside from the societal implications of this, obviously, were this to happen by 2027, you'd be living in a very different world by then, a year and a half, 2 years, right? So there are some complications to this scenario, aside from just, purely, WTF, what are we going to do when this happens? So there is some evidence that we're hitting a plateau in performance for these deep learning-centric systems. So that includes the latest models that are the generative reasoning or thinking models.
And there's also some evidence that scaling is producing diminishing returns instead of consistent step changes, as we've gotten used to. But nonetheless, the leaders of the tech industry are still telling us that AGI is imminent, like this guy, Sam Altman. So his argument is that superintelligence is imminent. This guy. The other guy's shouting. So he agrees with Amode that the superintelligence is imminent, but what he disagrees with is what the implications of that will be. So his argument is that, yes, the scenario you have is essentially, you know, the robots building robots scenario. Robots take control of all the production of other robots, and progress accelerates exponentially with the hockey stick curve. Most jobs go away. Most productive work is taken over by the machines. But us humans, we won't care because we'll just be so rich living off the spoils. We'll be happy to not work, more or less. So he points out two very minor things that need to be solved for this scenario to come to fruition. One of them is that this leads to wealth and power being concentrated in the hands of few people, you know, ostensibly not these people, right? The other one is that, you know, there's this little problem that we call the alignment problem, which is obviously a super easy problem to solve, right? So speaking of robots, but maybe better said of androids, Mark Zuckerberg is not to be outdone. This is Mark Zuckerberg wrestling Lex Friedman here. I'm actually not sure who wins this, but maybe you guys can.
Nobody wins.
Nobody wins. Nobody wins. So Mark Zuckerberg also agrees that AGI is imminent, but also disagrees with his peers about what will happen and what that will look like. So he does not think that the best outcome would be that all valuable work is automated and we all just live off the dole of the intelligent machines. He actually wants to bring personalized superintelligence to everyone, so democratize it, which sounds good, right? But that does involve Meta having access to all your personal data, right? So these are the titans of the tech industry. They're telling us that this is coming down the pipe in the next 5 years, right? But they have vested interest to drive narratives to their advantage. So in Amade's case, his company is very focused on safety, so that's an incentive for him to really, you know, whip up this anxiety. In Zuckerberg's case, he, you know, made his company building a social network, so that's really what he's thinking about, like your little AI buddy. So these folks do have access to the top secret research. I would never deny that. They know what's hiding in the basement, and I'm sure it's mind-blowing. But they also have a lot of bias. So how much can we really take what they say at face value? Well, there is a lot of criticism of this scale all the way to AGI paradigm. And in order to talk about it, we're going to focus on the current latest LLMs on the scene, and those are the reasoning or thinking models. So in order to kind of get into that mindset to think about this, we're going to define reasoning in this case as the action of thinking about something in a logical, standardized way. So for our purposes, again simplifying, let's think about LLMs as inherently stateless. You provide a prompt provides output, but then everything sort of evaporates in any prompt that you provide later. It's as if the prompt that came before never happened. So adding this processing, both pre-processing and post-processing, results in this process or this outcome where we have a model that appears to think. It iterates over the problem a couple times, and a lot of times that will provide a more accurate answer, a more complete answer, a little bit more depth. So oftentimes you don't want this. You have a simple question that's dealt with more by a non-thinking, non-reasoning model, and sometimes you do want it. And so one of the improvements of GPT-5, which a lot of you are probably playing with these days, is that routing happens automatically, right? Some prompts need more thinking to come to the correct answer, and some don't. But are these models actually thinking? Is reasoning actually what's happening? So there was a paper published recently by Apple called The Illusion of Thinking that sort of calls this paradigm into question. So they did research on reasoning models and found, for example, that beyond certain complexity, accuracy actually collapses. So that's a little bit counterintuitive to what we've been talking about, right? So to test this, they provided the models that they tested with controllable puzzle environments. So in this case, we have some puzzles that you may recognize, like Tower of Hanoi. Generally, these are problems where there are physical pieces that have to change places or something like that. There's some constraints placed. And the important thing is that these particular games scale with the number of pieces. So the models they used were Claude 3.7, Sonnet versus Thinking, so thinking versus non-thinking. Same with DeepSeek, V3 versus R1, thinking versus non-thinking. So one of the quotes from the paper that's notable is, they say, upon approaching a critical threshold, which closely corresponds to their accuracy collapse point, models counterintuitively begin to reduce their reasoning effort despite increasing problem difficulty. So not what you would expect. So let's look at that in the following graph. So you can see here where with like a simple question, both models seem to do pretty well, or a low number of game pieces. And as we complexify, then the non-thinking model collapses. The thinking model does well until they both complexity reaches a certain level that they all start to converge around 0. So one flaw that's been pointed out in this paper is that we have a certain fixed context window for these models, and we have a certain number of tokens that we can use, right? So the model runs out of resources and just collapses in, right? Well, actually, no. The paper does control for that. So the models they found failed to take advantage of additional compute when it's available, oftentimes. And that with the Tower of Hanoi environment, so the Tower of Hanoi question, at times the algorithm was actually provided in the prompt, and they still saw the same collapse, even with basically the instructions given with the prompt to the model. So that begs the question, in terms of thinking, reasoning, and intelligence, can we say actually that that's what these systems are doing? So how would we even know? So we have several benchmarks that we use to evaluate models. One is Humanities Last Exam. That's a very commonly used one. Another one is SWB Bench. That's for coding systems, to evaluate coding systems. But these are actually pretty weak in testing reasoning. They can do it, but not well. And they're really bad at testing for general intelligence. So we actually have a different benchmark for that called ARC-AGI. ARC standing for the Abstraction and Reasoning Corpus. So this was conceived originally in 2019 by a researcher by the name of Francois Chalet in a paper called On the Measure of Intelligence, where he says basically, AGI is not a system to automate valuable work. That is something that one could use an AGI system for, but what an AGI system is inherently is a system that can efficiently acquire new skills outside of its training data. So how would you test that? So for ARC-AGI, there are several test puzzles that are essentially simple for humans to solve, relatively simple, but very hard for machines to solve. So they need to be solved by at least 2 humans in 2 attempts. And there are actually levels to ARC-AGI, and right now we're at level 2. So level 1 was solved by GPT-03. It got the highest score in ARC-AGI 1. So according to ARC, reasoning systems break under certain conditions. So reasoning systems struggle with symbol interpretation. So a human could look at this and start to make some sort of sense out of it, sort of judge the pieces against each other, create some context where none exists, and that is not something that reasoning models are good at. Reasoning systems struggle with multiple overlapping rules. So keep in mind, these systems are not trained on these rules. So when there is an added level of complexity to the rules changing in relation to other rules, that is not something that the reasoning system accommodates well. Reasoning systems struggle with tasks where rules are applied based on context. So again, the complex relationships between rules utterly break these systems. So a quote from this paper that I think is interesting is that Chalet says, many AI researchers are implicitly conceptualizing the mind, the human mind, the biological mind, via the metaphor of a randomly initialized neural network. So we should talk about how neural networks are only loosely inspired by the brain. So that begs the question, would it be more useful to actually model the mind, model a biological mind? So right now it's quite trendy on Substack to talk about this question in the context of a certain animal. You'll find that the rest of the presentation is sort of a literature review of my Substack reading. So bear with me. Those of you that do sort of follow these threads on Substack may have seen some of these different articles that have been posted in the past couple months. But it is very popular to talk about modeling the mind of a certain very simple animal, the nematode. So a nematode is a very, very small worm. It's 1/200th the size of a Cheerio. So with this very small, simple worm, what sort of behaviors might we need to model? So if we're modeling this system of a nematode, what sort of behaviors would we need to be able to simulate? Anybody have an idea?
Movement,
Movement? What kinds of movement?
like fight or flight,
Being able to run away from danger.
be able to
What
find
else?
food.
Find food, maybe different kinds of food. What else?
Pretty much survival.
Survival.
Yeah.
The whole entire program is survival.
Reproduction.
I heard something.
Reproduction part survival.
Reproduction, there you go. That does factor in survival, but that is behavior. Right. So this nematode C. elegans in its brain has 300 neurons. So for reference, the human brain has 100 billion neurons. So the nematode C. elegans brain was mapped for the first time in 1986. So since 1986, we have known how many neurons this nematode has and how they're connected together. So since then, there have been many efforts to simulate the behavior of C. elegans, and all have failed to this day. So what will we actually need to? What sort of behaviors would we actually need to simulate if we wanted to simulate a C. elegans nematode? So I'll read a quote. So even between genetic clones of worms, some worms are fast and some are slow. Some are sleepy or really like to eat. Some like being next to walls. They swim towards food. They remember what makes them sick. They make decisions. They invent crazy new behaviors. They can hitchhike by organizing themselves into tiny worm towers that help them teleport onto bees using static electricity. So even with 300 neurons in this tiny little brain, the behavior that emerges is incredibly complex. So a good simulation of this worm would replicate this functionality and reliably predict what the future activity would look like given the current state. So all this to say, the behavior of biological neurons is not simple at all. So there are lots of states in a biological neuron, not just on and off. And we already know from what we looked at before that artificial neurons in a neural network are not like that. So an obvious direction for research to improve these systems would be improvements in the artificial neuron. And there is a company called Sakana AI, a Japanese company, that has developed a new architecture called continuous thought machines that does just this. So while a traditional artificial neuron has no state, stateless like we talked about, the continuous thought neuron remembers prior states. So really what it's learning over time can be thought of as a rhythm. And then what this does is it produces complex interactions with other neurons. So you can visualize these. So the visualizations here on the left are the continuous thought neurons versus traditional neurons on the right. So we have a lot of different states here. And those states are still dependent on what's happening with the other neurons. We also have built into this system, I'm not sure how, interpretability, which allows for the researchers to be able to see the attention patterns of how the system is looking at certain problems. So these systems are really good at iterative problem solving. So they're not specifically trained on mazes, but they're really, really good at solving mazes. Even more than that, you could watch their attention patterns, how they try and make it through the maze. So on the Sakana AI site, there's a lot of great videos of this, of visualizations of how the system is going path by path and trying to find a way through the maze. So up to now, we've talked a lot about neural networks. If you were playing a drinking game and you were drinking a shot every time I said neural network, we would all be really drunk by now. You might actually be enjoying this talk more if that was. So obviously, these are a powerful ingredient in AI systems. But neural networks can also be combined with other techniques. So a frame of reference for this is something called neurosymbolic AI, which is something that was conceived by an AI researcher called Gary Marcus. Gary Marcus is known as being a big critic of LLMs, but really I see him as thinking more about how much of the resources that are available or dedicated to LLMs. And really what he's advocating for is this combination of symbolic systems with neural systems. And so a symbolic system in this case is a bit more like traditional software, where you're manipulating variables, you have objects as abstractions. So these two paradigms really complement each other. You know, obviously the research is lopsided, but this is a direction that we could take things. So according to him, neural networks have a fundamental problem, and that's that they have a lack of a consistent world model. I just say oftentimes they just don't have common sense. Sometimes you're asking things that a human would just automatically pick up what you're putting down, and these systems don't really do that. One case that he really likes to talk about is asking image generation systems to produce an image of a horse riding an astronaut. So any of us would think about that as like, okay, that's kind of weird, but I see it sort of ironically, you're having the horse ride other things rather than things riding a horse. Well, this really confuses systems because they've never seen that. These systems have never seen, they don't have a frame of reference for a horse doing anything other than being ridden. So it really confuses them. So there are examples in industry of these neurosymbolic architectures. One notable one, very notable one, is the Alpha series from Google and DeepMind. So AlphaFold, AlphaProof, Alpha Geometry, really next level stuff. Those are all neurosymbolic models. And then according to Gary Marcus, a group responding to the Apple paper that I talked about showed improvements on the Tower of Hanoi problem, allowing GPT-03 to evoke code. So beyond augmenting neural networks, we could also just take a completely different design approach. So that's something conceived by Eric J. Larson in his sort of frame about thinking about this called AHI, or Augmented Human Intelligence. So this rethinks the monolithic model of superintelligence in such a way that I can only let him talk about it through this quote. So in his frame, the model is not the mind, and never will be. The design goal isn't to create artificial agents, but to build environments that support and extend human cognition. So why? Because we're always making a trade-off. We're always thinking about like the persistence of what the model does over time, over the context that is maintained over a series of prompts, versus adaptability, like when we want to change the subject, right? So we can use routing like with GPT-5, but that's very sensitive to edge cases, as we've seen with GPT-5. We could use basically databases. There's one that's called retrieval augmented generation that's very popular right now. We could somehow encode preferences as memory, but all these are sort of band-aids. They have a lot of downsides to them. And really, the best place to hold context is right here in the human mind that's actually designed for context, right? So with AHI design principles, the context is always outside the model and always belongs to the human. So it is always subject to inspection and control by the human. Context is first class, it is distinct from the model itself, and it belongs to the human. Completely different sort of design principle there. So these are a few examples of interesting research directions. At least I hope they're interesting. So we have background now. I promised you some practical examples, so let's go ahead and get into that part. So we're going to pose a couple scenarios, and the first one is, if you could just imagine for a moment, that you run a company. So you run a company. This is kind of what you're contending with, right? So, this level of scrutiny is what you're contending with. So for better or for worse, the LLM that I talked about at the beginning is the dominant paradigm. We're in a race to AGI, that is the prevailing goal. Big tech companies are spending big money building temporary data centers like this, and demand for hardware and all the other inputs is huge. This is incredibly expensive. And the spending is monumental. So this is a graph on CapEx spending by these very notable tech companies. Look at the increases over the past couple years. This is an incredible amount of money that these companies are spending right now to scale these models. So they can spend more on CapEx than us mere mortals, right? These increases are unbelievable. The background is the race to AGI, scale is all you need. So if you're in a company in the AI space, if you want to build an AI project, right, or you want to build a product that uses AI, leverages these techniques, how would you approach it given this dynamic? Okay, but you can probably guess I'm going to recommend you another Substack. So if you actually follow anybody that I talked about today, this is the one that I recommend to follow. It's by an article called Dave Friedman. It's called Buy the Rumor, Sell the News. It's spot on all the time. So given this paradigm, according to Dave Friedman, how can smaller companies keep up and compete with this? So he talks about the legacy paradigm of VC funding. So this relies on software's core economics. Focus on the software. So replicability. If I want to use Uber, I download the app, I create a profile, I'm good to go. That's all I need to do. So then defensibility, when your app becomes a verb rather, like Uber. Like you don't say like, I'm gonna get a car, you say I'm gonna get an Uber, right? So that, sort of just puts you on the trajectory. You have marginal cost, as I said, you're just downloading an app. That doesn't really cost much to replicate, it's approaching zero. So again, we're just talking about copies here. And then we have this classic disruption pattern, right, where it's winner take all. So all the things we talked about before, the defensibility is a big one. Your company becomes a verb. We're going to get an Uber. You enter the market. You identify pain points in the market. You enter said market. You undercut your competition. You undercut the legacy business. You displace them. You become the thing that everybody uses, the hot thing that everybody uses. And then once all that's done, you can raise prices to whatever you want. And your funders are very, very happy, like the funders of Uber or Airbnb or whatever company, from this paradigm, right? So a lot of VCs these days think that AI is just going to be another wave of this pattern, but they're in for a rude awakening. What is the new reality? I bet you guys could tell me by now. So hundreds of millions in compute or more. Big, big spending on compute. Lots of inputs that require infrastructure. This is almost more like you're building a utility company, right? Access to hardware. Everybody's competing for this stuff. There's only, especially with tariffs and all the other crap that's going on, there's a lot of competition for this stuff, right? And then access to data. This one's a little bit more out there, but yes, you need a ton of data and not everybody has access to the data. So given this paradigm, what companies survive? So you run a company and you want to get into this space. What should you have to succeed? So you need a moat. So your moat could be leveraging existing connections with industries like healthcare, like enterprise SaaS, legal tech, basically integrations in a certain niche. You know this space better than anybody else. Proprietary data. If you've got that, then that is a huge advantage over your competitors. You need a lot of it, and if we're going to use the example of healthcare, you have a lot of other issues that are going to come up involving privacy and security, so that's something to think about. Inference. You fine-tune or build your own models. You build out your own infrastructure. This one's interesting, and there are a lot of use cases where smaller fine-tuned models are going to do better than the big models. So that's something to think about. You're building infrastructure. So not everything is just the LLM and the inference engine. There's a lot of other things that go into this. These are your snowflakes, these are your Databricks, these are your CoreWeaves, the other companies that sort of support these applications. So if you're thinking about starting a company like this, according to Dave Friedman, what should you ask yourself? So ask yourself, what prevents OpenAI from doing this? So if I'm building a layer over an API like OpenAI's ChatGPT API, why should I expect that someday ChatGPT might just incorporate this feature into their core product? What do I control that is not model dependent? Different version of the same question. What am I providing that does not depend on the underlying model? And then what happens if API access is revoked tomorrow? So this is not just what's your plan B, this is part of your value prop. What do you bring that is not dependent on the API that you're consuming? So that's Dave Friedman. What do I advise if you're in this situation? So I advise always product focus. So what product or service are you passionate about building? Start there. If you're really committed to building something and you really believe in it, that's the first step. Step 2, who's your customer? What do they want? What are they actually going to pay you money to give them, right? What would it bring to your customer that's truly unique. What do you do that nobody else can or will be able to do? Then, after you answer all those questions, talk about your stack. So your stack doesn't even need to have AI in it necessarily. Maybe, these days that's the best thing to use, maybe not. So if you answer the questions, this last question is going to be a lot easier to answer. So not everyone here owns a company. So we're going to look at another case study. This one hits close to home for me. So you're a software engineer. If you're a software engineer, you're probably getting a little nervous now. You're getting a little hot under the collar because these tools are getting better and better every day at writing code, right? Right? Well, the time has come for me to recommend yet another Substack to you. So this one is by an author called Luca Rossi. So it's called Refactoring.
It was a testing.
So it's called Refactoring, and especially for engineering managers. I think this is one of the best Substacks that you can follow. It's really, really, really good. So Luca Rossi wrote an article, kind of I think probably what he thought was just going to be like this throwaway article around the beginning of the year called "Will AI Replace Engineers?" So he talks in the article a lot about capped versus uncapped value, and it's sort of a weird concept to figure out. So I'll give you an example. So I have an apartment. My husband and I have an apartment. The apartment gets dirty, and we don't want to clean it, right? We're lazy. So we're like, who's going to clean our apartment? So we could have a bunch of kids. It's kind of old school, right? And then assign all the kids chores, and then the kids clean the apartment. Problem is that it's expensive to have kids, so we don't want to have too many kids. That would be cool. We want to have just the right number of kids. So how can we improve the efficiency of doing these chores to the point where we only need to have like a ton of kids, right? Like maybe one or two, right? So let's say that we find this magical way to improve efficiency. I'm still in this scenario only going to have one apartment, right? My apartment is not going to get bigger. There's only a certain amount to clean. So that is capped value. Whereas uncapped value means with efficiency, with the growth of efficiency, there is actually more things you can do. There's more value you can bring. So Luca Rossi makes the argument that software engineering is like that. So with more engineering time freed up, because we don't have to do boring stuff anymore, there's more opportunities, and with more opportunities, there's more business. So while the tech grows linearly, the problems that we can solve scale exponentially. Like there's no theoretical limit to what we can do, right? So here's a graph, not the best graph, but it kind of illustrates what we're trying to talk about. So productivity increases, keeping the lights on, just boring stuff that occupy our day-to-day becomes less of a priority, and then us intrepid software engineers have more time to dream about all those things in the backlog that we'll never get to, those things that we would never even dare to scope, those features that we dream of building that will probably never get built, now become possible to build. So one quote from this article that I really like is, he says, bad companies will use extra productivity to cut costs. Good companies will use the extra productivity to make cooler stuff. So in this case, what is an example of a good company, given this paragraph? So this is a LinkedIn post from the co-founder of a company called Clara. So you may know Clara.
Yeah, sure.
Digital payments system based here in Latin America. So this co-founder is basically positing Clara as an AI-first company. So what are the characteristics that make this maybe a little easier for them? So this is a young company, both personnel, code base, products. They're building this company culture from the ground up, right? So they're making AI tool use native. There's nothing to change because they're just now building this company culture. So according to him, the extra time that is produced by these efficiencies, produced by these AI tools, are funneled towards up to 10 side projects that each individual contributor is expected to do on the side. And then these side projects, if they really have legs or something that starts to take off, can become new products or new features. So that's pretty cool. But this model is not going to work for everybody, right? It's dependent on a variety of factors. An older company with a legacy code base, if you're trying to port your legacy banking system from COBOL to Rust, or right? Like this is going to be a lot more difficult for you. So when you're integrating AI workflows, what should you think about? So what should you think about as you're incorporating AI tools? So the number one most important thing is culture. What is the culture of your company, your team, your personal identity as a developer? You know, what works for you is not going to work for everybody else. So start there. What are your values? How do you work together now? And then that will help inform how you integrate these tools into your workflows. So what is appropriate for your industry? I'll pick on healthcare again as a canonical example. For your healthcare company, you're going to have big sort of issues around security and privacy that are not going to affect everybody else, and that's really going to really heavily affect how you think about how you incorporate these tools. And then what are your biggest bottlenecks? So I would wager that your biggest bottlenecks are not the things that these systems are going to do out of the box. So these systems out of the box right now are really good at vibe coding. We all know that. We all vibe code. But a lot of problems require a lot more complexity. Like I said, refactoring a code base, porting from one language to another, stuff like that is going to take a lot more setup time. So it may not be the best use of your time right now, but it's something that you can maybe put on your roadmap for some time in the future, as you're trying out smaller things, trying to build some institutional learning. So at the end of the day, we're asking the same design question that we've always asked ourselves, which is, what do we build ourselves versus what do we leverage? What do we build versus what do we buy, right? So it makes me think about working as an engineer, mentoring and supervising younger engineers in San Francisco in their 20 teens. So we were getting in those days a lot of people fresh out of boot camp, and in those days, it was all about the JavaScript frameworks. A lot of you probably remember that. And by JavaScript frameworks, I mean like hundreds of JavaScript frameworks. So, in those design conversations, it would just be like, oh, well, like this library does this, and this library does this, and you just talk about this way, and you got this, and this, and it's like, and, right, have fun. So you kind of find yourself being this grumpy old developer saying, oh, well, they're not even programming, they're just kind of like stitching together this code that already exists, kids today, Whereas, like the generation before me looked at us and they were like, oh, well, if you're using JavaScript or Python at all, that's not real programming. You should be writing everything in pure C. You should be writing your own Linux kernel drivers, So every generation has that gap, right?
Exactly.
So at the end of the day, what we're really balancing in these design decisions is we're balancing speed of developing something versus the risk of being locked into using something like one of these libraries, right? So what is the speed versus risk trade-off with something like a JavaScript library? This is just kind of for a reference. So tight coupling, again, are you just making a thin layer over a couple really common APIs? And in that case, what's your value prop? Maintenance, if you're totally dependent, if you're totally locked into using this great open source code base, what happens when the people that support it have 10 kids and then stop supporting it, right? that then becomes your problem, and you may not want that problem.
It's a real problem.
It's a real problem. It really does happen. Security, guess what? Their security flaws are your security flaws, unless again you want to pick up and fork it and start maintaining it yourself. In which case, you might as well build it yourself from scratch, right? So these are the trade-offs for a software library. So let's apply the same metric to an LLM. Let's say that you're using an LLM to generate code, right? So what are the risks to that? One would be you can't trust them all the time. Sometimes you can, but you need a human in the loop. You need to supervise them, period. So there's a lot of room to play with those loops. You can talk about sort of like cadence of checking on them, what are the checkpoints, what's the workflow, that kind of goes back to the workflow discussion from before, but you need to check them, right? You need to check the work. So then what's the next problem? This is what I'm not going to dwell on, but I imagine that if you integrate these workflows and you really start to depend on these tools, then your knowledge starts to atrophy. I think this is especially concerning amongst junior developers that don't have a background of not using these tools. How are they going to learn? How are they going to understand everything that's happening, right? So with more context, and this is especially relevant with things like MCP servers, MCP servers, you're providing more threat surface for potential attacks. So that doesn't necessarily mean the chance of an attack, like your threat level goes up, but it does mean there are more opportunities for threats to manifest. And then another really important one that is a pretty big jump from, like depending on an existing library that's versioned, is that the output is non-deterministic. So if you're expecting your code producing tool of choice to produce the same solution every time, guess what? Probably not going to happen. So that may be acceptable to you, it might not. Right? It's all about what you're trying to do. So hopefully thinking this way is starting to alleviate our career anxiety a little bit, and we're thinking about like, okay, well, if machines are sort of replacing what we're doing now, what else can we do? So that's ultimately how I would like for us to all walk away thinking about this. So science fiction has shown us, over the course of 100 years or more, that in the future we can expect things like colonies in space, flying cars, interstellar travel, all sorts of cool stuff, right? Well, when we're looking at that, how do we think that gets built? So I think that this place that we're in right now and this anxiety that we're feeling is a bump in the road on the way to that future. So if new efficiencies and new capabilities are sort of taking away something from humans that humans have traditionally done, and you're really invested in your craft as I am as a programmer, it's our job to widen our scope as much as possible and think about what this frees us up to do next, to dream big and build that incredible future that we know is just beyond the horizon. So that brings us to the end of our discussion. So I hope that you have learned a little bit more about what's going on in the industry, that we were able to demystify it and sort of clear away some of the cobwebs. I hope you understand more now about the inner workings of these technologies, and that will help you make better informed decisions about practical applications that will improve your life and your career. I hope that you'll be able to better anticipate future directions for this technology and be prepared as they come. And I just want to end by saying that I believe that these tools and applications, as they are now, as much trash as I talked about them over the course of this talk, they really are magical. If you leave aside all the hype and you just think about what we have access to, it's magical. It's incredible. There's so much cool stuff that we can do. So our job is to put those tools to the best use for us as humans. Thank you.
I think the lights are over there. Not really sure. Hopefully, there we go. Blinding lights. All right. Do you have any questions?
Yes.
It's really interesting. It's very interesting the way you see things. So I'd like to ask what you didn't talk about the open source part and the open weight models. And for me, it's a game changer, but I don't know. I don't know what to think about it.
I agree. I felt like it was a little, I feel like that's almost like a whole another topic that we could spend 30 minutes talking about. But I would recommend a Substack, or I'll recommend a new Substack called Interconnects. So what's a couple things I can say about that? Regrettably, maybe, or maybe it's like a silver lining in the Trump administration's plan, AI plan. There's a lot more sort of resources or a lot more attention that I think is being sort of gestured towards the open source movement, because the Chinese models are generally open weight, open source. A lot of people have gotten a lot of mileage out of fine-tuning Quen, which for the record I think is a great thing to do. There's some people consider it to be potentially a security flaw, but take that with a grain of salt, right? So there are a lot of open weight, open source models being developed in in the West, and so hopefully that will be more of a trend going forward. Anyone else have a question?
What about energy? Are you with all this stuff? The Chinese have more power, like maybe 100 more times the US or the West. like right now. Like you compare things like from that perspective, they're already winning the game. In terms of scaling up the whole AI industry.
Yeah, I mean, there's a couple different ways you can think about it. Is it a waste of resources? I think for right now, probably, but I think these fits and starts are kind of how industries develop, how technology develops. So hopefully, if there was a radical change, like DeepSeek, for instance, Chinese model, which a lot of people are probably familiar with, is a much more efficient model because of sort of the lack of hardware in China that was a forcing function to make them develop a model that's a lot leaner, right? So that's the sort of thing that can exist, even in that, as you say, like we talked about regulation, and obviously in China those regulations are a lot more flexible than in the West, generally speaking, and marshaling those resources is easier, but yet, and they're pretty good about fabricating chips and stuff like that, and yet, in that market, we're producing these much more efficient models that require, orders of magnitude less inputs to train. So, I don't know if that answers your question.
Yeah, I think in part it answers the question, but I think that they're developing. I think the models are gonna. I think this is just my personal opinion that might try in the short term, and then they're gonna overpower the rest of the models. Is gonna be non-open source models just because they have more resources at their disposal, and China has plenty of those resources from different angles.
I mean, that's one reason why the Trump plan exists, right? For better or for worse, we can say which will. I'll just say it. I'm not a huge fan of it, but I mean, there are some good aspects of it, and it does. I think the problem with it, the good and bad thing about it, is sort of the urgency to think about open source models, and really put some effort around opening up the landscape, so it's not just these same tech companies that have absolute control over this industry from a national security perspective. But at the same time, I would just say this is a very unpredictable industry, and so even though we're in a race, as I framed it, to AGI, the reason I bring up DeepSeek is that DeepSeek really broke this paradigm for a minute. I think people have moved on and forgotten about it. But the fact that DeepSeek could be trained to compete with GPT with much fewer resources and just be such a lean and powerful model, really threw this dynamic into question. And there could be, I feel like on the way to AGI, which for the record, I do think we will actually get there eventually. But I think that there will be other technological advances that scramble this whole paradigm.
There's an AI, Manu, it's Chinese from China. This AI. Manus, yes.
I haven't heard that one.
You haven't heard? No, because I have used it a bit, and it's like quite good. Yeah.
Yeah, the open source scene in China is really there's a lot of cool stuff, but there are other options too.
Looks like it's a combination of many models. It's actually an agent. It's more an agent than an LLM.
I see. Okay. Yeah, and that's sort of with this paradigm that I'm talking about here. That's kind of the stage that we're at, right? It's sort of like the actual just pure inference is not necessarily going to be enough. There's a lot of other components in the mix. Did you have another comment you wanted to make about it?
So
did you have a question about it? Or?
No. I wanna know if some friends from Europe told me like 5 years ago that China was like the leader in AI, but I was like a bit accepted at that moment, and 5 years later, I said, okay, he was right. And yeah, the amount of money that you said, the plan of the Trump plan close many things in order to reach those guys. it's very difficult to have an opinion about it. Yeah, and also the energy, planet, and there are many things.
Yeah, I do wonder if it's the best, if what we're doing, what I'm describing is the best use of resources, but I do believe that whatever infrastructure is being built now, regardless of what happens, will be used for something. So that's maybe one way to think about it. Yes?
So at the end, I'm sorry for being late, but Ivan will blame me.
Words.
He's a genius. By the end, you said this is a magical tool, that the things we have access to are magical. And I pretty much share that vision of everything we have in the contemporary world with all the tools technology uses. And then you said, what matters the most, or like something like that, will be how we use it for the best outcome for ourselves as human beings. How do you think we can use it? Like, what can we do? Like, even if you're not an engineer or a programmer like me, like, how could we find that vision, that use?
Yeah, I mean, I'll try.
That's okay. You prefer a technical question?
If you want a second, we also, the AI CDMX hosts events, workshops, specifically for people that are less technical. At least a couple times every few months. So we've had my wife runs some classes, like 3-hour-long workshops where you come in with a specific task, and she takes you through, without needing to know programming stuff, how to automate it from start to finish using AI in the middle, all that kind of stuff. So there is lots of stuff available, and you can find stuff on YouTube. If you join the WhatsApp group, people will happily provide you with all kind of resources. But what I assume you.
Yeah, for example, well, if I can
Yeah,
say
go
something,
ahead.
the guy from Repl is a company. Yeah, it's they have the objective to, the vision to get 1,000 million. I don't know, it's a huge amount of people to use the AI like something like every people use it in order to solve any kind of problem. So he's from Guanajuato, Mexico, the CTO, I think so.
Wow.
Yeah. He was in Google and also in Google and I don't remember in Microsoft. Yeah, in internship. And I said, oh, okay. That this is when I listen the purpose, not the purpose, the quantity of people and the effort that they are doing in order to make it the interface very, extremely easy for people to use it. It's like, okay, maybe that's the way for common people to solve problems.
Yeah.
Yep.
Yeah, I mean, I think the quote from earlier about how bad companies will use these tools to cut costs and good companies will use these tools to build cooler stuff. I think it applies just in daily life too. So if we automate stuff, and there's this moment where it's like, oh, well, I don't want to try, like I put a lot of time into doing this, but okay, now with what I know about this, computer does this. Now what can I do? Like, it's even more even more incredible. I think that's the hope. That's the hope that I'm going to leave you with. That's the hope I have for you.
Okay. Thank you.
Any question on the floor?
Do you guys see any specific opportunity like markets, like here in Mexico, maybe or Latam, where we could approach all this technology? Like in the US is already spoken, and here in Mexico we have the opportunity to expand and to create business models about it.
I think there's endless opportunity here.
Do you guys have like a specific sector, maybe finance, maybe insurance?
Like all the above. Yeah, I mean, I think personally, if I was going to kind of nudge people towards any trend that I think will be really important, it's this idea that you might have a pipeline where you're fine-tuning smaller models rather than like move away from this monolithic model of building these systems and think about just focusing on a small problem. I think there might be a trend someday in like really small networks that just solve a very specific thing that's sort of fit in or part of the composition of like a bigger pipeline or a bigger application. So that might be an area where you can kind of leapfrog over this stuff here. Sorry, we haven't had another question back here. Did that answer your question? Okay.
Yeah, based on your own criteria, when do we reach the AGI?
When?
When?
Or will?
I think we will, and I think just spitballing, being sort of like science fiction-y, I think it will look much different than we expect it to look. But I do think that the better thing to do would always be thinking about how we develop this machine, which is the most efficient thinking machine that we have, right? That has like, you know, hundreds of millions of years of billions of years of evolution behind it. How do we augment this? I think is the way to get around that. But is that how it's going to go down? I don't know. There's a lot of money behind this as well, and there's a race behind this. So.
If I could piggyback on that for a second, there's that was one of the first topics, like one of the first 3 meetups we had like 3 years ago. And under the definition that we used then, we already have reached AGI. So it really depends on what definition you use, because if you say, oh, it can do a wide range of tasks without external assistance to a certain degree of success, it depends on which metric you're using, but we've already raised, we've already beat that metric. And if you look at the benchmarks, they're constantly evolving, because once you reach the maximum of those benchmarks, you have to make better benchmarks, right? So like this idea that like, oh, when are we going to reach AGI? It depends on who you ask, right? It depends on, I mean, there are definitely strong opinions about that one way or another. And I totally agree, that's really, it's not a big focus. For me, the focus is just what you can build with it. Can you make it do the things you need to do? Is it matching humans in a wide variety of tasks, or what those tasks are, what those tests might be, Right. That's a subjective thing.
Well, nobody laughed at my Cylon HAL, Skynet slide, but that's obviously a big thing that we should. I mean, it's cliche, right? Because we have all these dystopian science fiction, but that's also a concern, right? Alignment, alignment is talked about today in a really kind of flippant way. I think it's a pretty hard problem. Humans are fundamentally unaligned, right? Like if you can't align a human, how do you expect to align a super intelligence to human values, whatever those are?
Crowdsourcing taking that route.
Good.
There was another question in the back.
Just continue the previous question. Do you think the fear of traditional companies, those established companies, they're afraid to adopt LLMs, they're afraid to share their data? Do you think it's going to be a challenge to reach AGI, or do you think it's going to be AGI but in a different way, not like it's proposed by some open guys?
It's a great point, and there's a lot of great stuff to read on this exact subject. So there's a long article that was produced by some researchers at Stanford called AI is Normal Technology, and this is a point that they make much better than I can, which is that if you look at technological advances over the course of history, like electricity is a great example. When it's available, was sort of when it's developed as a product, let's say, there's often a big gap between that point and when it's actually adopted. And big companies are going to be very risk averse. There's a lot that I've talked about, like the non-deterministic aspect of these models is a big one. That is going to be a big stumbling block. Okay. But I think there are a lot of companies that are just going to bite the bullet and do what they can, and there may be kind of a back and forth. Like they'll just really buy into it to appease their shareholders or meet some KPI metric, and then there'll be a security incident and they'll walk it back, and it'll be a process of that over many years.
Okay, about the labor market for software engineers, what are your predictions for the next few years? considering all your experience and knowledge about this?
It's rough, but I think what I just said is going to be, there's going to be a lot of rinse and repeat. You know, like in 2026, my prediction is that we'll see a lot of security incidents involving these developer tools. They'll become much more high profile. And then, you know, companies that are very like buying into it heavily will have to walk back a little bit, but not completely. So I think, you know, from your perspective as a recruiter, I think it's really important for those of us in senior positions to continue mentoring junior staff members. And the way that I do it is, like, whether I tell my junior folks to use it or not, like, they're going to do what they're going to do. But they need to be able to defend what they're doing verbally and written. So, like, writing documents. There's no, like, if you're saving all this time writing code, like, you can write a document, right? You can explain it to me. You can have a conversation. And that's more like, so what does that do? That sort of compresses the trajectory of their career, right? And so, like, they need to get to that point that you would think of like a leadership role faster, right? Because they're going to be leading these LLM-based tools to write the code largely. Okay, yes.
Well, I have many questions, but well, one is, as you said, like, what do you think what do you think are the next jobs that are going to be created as a side effect of the AI? As you said, like, security is a big hold up.
Yeah. Well, I mean, again, like putting on my science fiction hat, like I could see there being sort of a cottage industry of like LLM or AI system trades people, you know, like you call your plumber, your electrician, or your like AI person to come and like fix your system, right? So that would be a very interesting outcome that sort of explodes our idea of who's an expert, you know.
Okay.
I can speak to my industry. I know that infrastructure is something that has been completely exploded by so many things over the past 10 or 15 years, and this is another sort of explosion. So, you know, as much as like one program can just be sort of vibe coded or spat out, like you add so much infrastructure to make that work. And these new applications I'm talking about that will come, cool stuff.
Yeah,
it's just going to require even more of that. So.
Exactly. Okay.
There was a question in the back. Somebody had their hand up.
I was just going to say that I had to debug vibe coding.
No.
How was that?
I mean, I believe young developers will have to do this, and they will learn.
They will. Bless their hearts, they will.
Yeah. They will have to.
Yes.
What are your sources of information? Is it mostly reading, or do you still spend a lot of time in San Francisco and talking to people live?
Yeah, I mean, I think communities like this are great. I'm missing that in San Francisco. This discussion will be much different there. We're having a lot more fun. You know?
Free time is for other people.
I mean, the culture there is what it is, right? And people are operating at a very, very high level, and it's also very sort of self-selected. You know, you have a lot of the same sort of type of people, and the thing that I love about being here, you know, is that there's a lot more. The energy is a lot more. There's a lot more openness and a lot more excitement. You know, I think in Silicon Valley right now, everybody's just kind of trying to hang on to their job. Like, this is not a good cycle. Like, if you look at what happened with Windsurf, like that is not good. You have a lot of people that work really hard for equity, and then at the end of the day, the company just gets hacked apart. You know, the valuable people. But again, when I'm talking about self-selection, like these are the same personality type, intelligence level, perspective. They may have slight variations, and I'm not trying to say that they're bad. Like, these are really smart people that know a lot, and their perspective is important. But like, you have like Mark Zuckerberg is recruiting like a different version of the same person over and over right now. So I think I enjoy having a bit more diversity of thought and perspective. I think eventually that's gonna be worth something like monetary.
What about education? Should we go to school?
Do you have to read books?
Okay, let me pose a nightmare scenario to you. So there's a solar flare and it knocks out all of our electronics, right? Who is going to be the most valuable person on your block? The person that doesn't just like punches everything into ChatGPT or Google or whatever. The person that actually knows how to do stuff. Right?
Exactly.
So think about it that way.
Since knowledge has been commoditized, so to speak, so what's next, really? Right? You go to school for human relationships, playing sports, getting drunk. That's not
Been doing good for a
I
while.
it's not so fun. It's just, I don't know if you really want to go to all those different steps and, recently, the past week or two, this many college students and grad students kind of quitting MIT and Harvard, all these big colleges, because they say, hey, I might lose this great opportunity. The first year, second year, they don't want to study anymore. Now they want to go for the big bucks, and so things are changing dramatically.
Okay, if I can pick that apart, the getting drunk party relationship piece, I think is actually really important. It's really important. You have
crucial.
Yeah, I mean, but as far as education, is the education system going to have to change? Yes. I mean, should people still learn stuff? Yeah.
The problem with that is it's just become so expensive and not very affordable in some places. So
yeah, I mean that's a huge problem, and these tools have their role to play, but if you think about what a tool is sort of made to do, people are going to use it for that. So I think the vibe coding thing, a lot of people in my industry say oh, these vibe coders, whatnot, but that's what the tool is made to do. The tool is made for vibe coding. It's people cheating with ChatGPT. It's well, that's what the tool is made to do, is access this information that you're testing for. So that's just reality, right? I mean, so I guess my point is, how can we reframe that where we're not either making these tools better or making them focus on things that are a little better? I think you see that with sort of ChatGPT that's tuned to learn stuff. Whether anybody will actually use that, I don't know. But we need to reframe. We definitely need to reframe, and hopefully these tools can be used in a way that democratizes information in a way where people are learning, and it sort of increases the efficiency of being able to teach and learn.
Yeah. Well, my opinion is the other way around. Is as a senior developer, you have to be, you have to study more. You have to check more juniors. I live that situation. A couple of junior developers developed a system in 1 year and a half, and the system was horrible. It doesn't work. After 1 year using AIs, so we have to do it again because no one supervised those guys. So they didn't know how to, implement patterns and architecture and all of things.
Make them explain it. Sit some really important people down and put them up there and make them explain their system. I guarantee you they'll learn fast. Put them in front of a client, if you have one that's open to that, So it's
a bad sales idea.
It's not a sales. Any other questions? I know we're running really long.
There's one more question. All right then.
All right. Thank you all so much.
Thank you.
If you want the social media QR codes, WhatsApp QR codes, all that stuff, it's over at the bar. Take the QR codes. So should be easy to find.